Graph to come on, hopefully. He was with me a minute ago. Hold on a second. See where he's gone. Here he is. Hi, Altaf. You're here?
Hi.
Yeah. Right. Morning, everyone, again. As I mentioned earlier, we're going into another key topic around corrosion under insulation. And we've really got an expert here in the form of Altaf. Has really spent a lot of time and really got some very, very incisive information on how to, this is a key issue that has a massive amount of impact on most of the companies that I've ever dealt with. So I'll get out of and let Altaf start his presentation. All the best, Altaf, and thank you very much.
Thank you. Thanks, Felix. Let me start with thanking Felix and the NEPIC team, John and everybody for giving us this opportunity to do some great work in the region. So thank you very much. I'll just share my screen because Felix got me on a clock. He's told me I can't go over my time limit. So I'll quickly share and hopefully we won't have any technology problems. Can you see my screen, guys? Just somebody tell me you can see it. Hello? Hello?
Are you okay?
I'm just wondering if you could see my screen and everything.
You see lots of things on your screen, but we need to get it into slideshow. Yeah. You had it. Yes, we could see your screen, but we need to see you had the first slide up. Can you do it now?
Okay. Is that okay?
Yes.
Are we ready to go?
That's it. Yeah. Go. Yeah.
Great. Okay, good. Okay. Yeah, so thanks, Felix. Thanks for that. I'm going to talk a little bit about corrosion under insulation. And let me quickly start with giving you a quick overview of Aspen Aerogel. We're an insulation company, and our products are really focused on the technology of aerogel, and all our insulation products are designed with this core DNA, basically based on aerogel technology. Now, the key difference between our insulation product and traditional insulation products is really that technology, aerogel. Aerogel is 98% air and 2% silica. So, it's the lowest density solid known to man, and it has the best thermal properties of any solid known to man, as well as acoustic properties. And the key thing here is that we actually weren't the people that invented aerogel. It's been around since the 1930s. We managed to use our patented technology to encapsulate that aerogel into these blankets that are being used around the world. Aspen Aerogel was formed in 2001. It was actually a spin-off from NASA, where the product was originally used in space suits and other NASA technology. So we were a spin-off, but we moved into the industrial marketplace around 2006. And when we moved into the industrial marketplace, between 2006 to date, we have now around $1 billion worth of installed base. And that equates to around 600 million square feet of the product installed. So although you might be hearing about the technology today for the first time, it has actually been around, and it has a comprehensive install base. The majority of the operators in the oil and gas sector are using them, and also the chemical cluster is using extensively in a number of key areas. One of the key areas they're using is corrosion under insulation, and that's what I'm going to focus on today. So let me quickly dive into our 4 products that our where we use our product. And the first one really is Cryogel. Cryogel Z is our cold product, and this really operates for LNG markets, NGL, and so forth. So the key temperature range that you would use this product on is -200 up to 125 degrees C. Key difference between our insulation product and traditional insulation products is our product can give you more than one service. So typically what you find is in the LNG sector, you'll need thermal, you also need fire protection. Our product gives you both. Just by applying Cryogel, you can get both your thermal requirements and your passive fire requirements, as well as acoustics as well. So it meets pool fire and jet fire requirements as well. Our Pyrogel XE product is the product I'm going to be focusing on today, and this is really our flagship product specifically used in that CUI space, corrosion under insulation. That's rated between 0 and 650 degrees C, and it's a hot product, basically. The other product is our HPS product, and that really is designed specifically to work in the hot end of the spectrum for cokers, high-pressure steam pipes, and so forth. And the thermal conductivity for this product is very low at temperatures above 400 degrees C. The final product is, again, similar to Cryogel, is a dual service product, which is known as Pyrogel XTF. And this product, once again, is an excellent product for where you need thermal and fire protection. So traditionally, where you need a thermal and fire protection product in a CUI space, you would use something like mineral wool, then you would use your cladding, then you would use something like an intumescent or a cementitious paint to give you your fire protection. The big challenge is when you need to do an inspection, you've got to remove your cementitious paint first, then you've got to remove your cladding, and then you've got to remove your insulation, do your inspection. So it's a big issue. With Pyrogel XTF, it's a blanket. You just apply it. You put your stainless steel cladding over the top, and when you want to do an inspection, it's just a matter of removing the cladding and removing the insulation, doing an inspection, and then reapplying it. It doesn't become a major event. You don't have to wait for turnarounds and so forth to do inspections. So it provides not only CUI protection, it provides thermal insulation, but also fire protection as well. Okay, so if you look at our thermal conductivity curves, you'll see the Pyrogel and the Cryogel, in terms of thermal conductivity, are the lowest in the industry, basically. Most of the people on this seminar today will have plants, and their process temperatures will tend to be, majority of them will be below 300 degrees C. So if we look at around 315 degrees C, you'll see our thermal conductivity is around 20 milliwatts per meter Kelvin. If you look at the equivalent mineral wool thermal conductivity, you're getting up and close to 150 milliwatts. So we are significantly lower in thermal conductivity. And what that ultimately equates to, you need much less material. So typically, you would need, for 300 degrees C, anything between 60 to 100 millimeters of mineral wool, depending on your actual requirements. You would need anything between 20 to 30 millimeters of Pyrogel to meet the same requirement. So we will always be much thinner, and that obviously equates to more space in your pipe rack, and less metal if you're designing a pipe rack from the ground up. It's the same case for cold temperatures. Typically, we will be 50% thinner than any other traditional insulation products out there in the marketplace. So let's start with CUI, which is the topic that we're going to talk about today. And a quick brief, I'm going to talk about CUI, and I'm going to focus around the NACE RPZ0198 standard. But the key thing here is that what I find in the marketplace is when people talk about CUI and they demonstrate testing, they'll usually show you testing that they've performed. The testing I'm going to show you today is independent testing. So the testing I'm going to show you is testing done by Shell, Exxon, and Equinor. None of the testing is Aspen testing, and I think it holds more credibility if it's independent testing. And also, I think the other key area I will talk about today is a case study where we revisited a plant after 12 years of our product being installed in really an area where CUI was prevalent. And we some evidence around how the product performed over that 12-year period as well. So hopefully this evidence is a bit more compelling and also gives you some confidence that our product will perform exceptionally well in a CUI environment. So let's start with a brief history. And we look at CUI in 3 different cases. Number 1, what we call cold service. And this is really quite an aggressive type of CUI. It's really quite prominent in the Middle East. And the reason for this is really because the delta between the temperature during the day and the evening. If you look at somewhere like Kuwait, where the temperature in an evening might be as low as -2 degrees C, and during the day it may be as high as actually 40 degrees C. So you can see it's quite an aggressive kind of CUI caused by condensation mainly, basically, which gets trapped underneath the insulation. The other kind of CUI, which is not as aggressive, you can see that by the number of dots here, is what we call dual temperature or cyclical CUI. And this tends to be where the process actually travels through the CUI window. So here we're looking at a CUI window of 0 to 200 degrees C. That's really predominantly where a CUI tends to occur. So if your process is either operating in this temperature range or is traveling through this temperature range, and you have insulation on your pipes or your vessels, you will experience some kind of corrosion underneath that. And you'll see this kind of corrosion, cyclical corrosion, is not as aggressive because the actual process travels through the corrosion window, ends up at a higher temperature, but then maybe turned off on a weekend and so forth. The third type, and this is really quite prominent, and we see a lot of it in Europe, is what we call hot service corrosion. And pre-1973, there was very few examples and cases of this because not many people insulated between 0 and 150 degrees C because the cost of energy was very low. There was the oil embargo in 1973, which meant that there was a business case now to insulate in this temperature window. And many companies used what the traditional insulations were available to them. So they used fibrous cementation materials from the hot end of the spectrum, and they used foams and cellular glasses from the cold end of the spectrum. And what we find now is quite an aggressive type of what we call hot service corrosion in that space. And this really is caused by the insulation. So by simply actually applying the insulation in that space, you are increasing your corrosion rates by 20 times. So it's a real thing, and many people, we're seeing many instances of this around Europe, basically. You know, at one site, and this is actually a site in Germany, in 2016, they reported 50 CUI incidents alone. You know, so it is a thing, and that, you know, understanding the region. I'm from the Northeast. I live in the Northeast most of my life. I know we see a lot of rain here, and it's prominent in the Northeast. So many refineries and the petrochemical industry is spending up to 10 to 30% of their maintenance budgets fighting CUI. I'd be really interested if there's anybody on the presentation today about their views on that and whether that is genuinely the case. So let's talk about how Pyrogel works in this environment. And the first thing we'll discuss is how Pyrogel behaves when it comes to a water event. The key thing here is, Pyrogel is hydrophobic. So you'll see that first video there where we're actually pumping water. The water staying on top of Pyrogel. It's not allowing any water to come through, but you can see the jet at the bottom pumping the water through. So it's not only hydrophobic, it's what we call vapor permeable. So it's breathable. So the key thing with CUI is as long as you can keep the moisture and water away from your pipe surface, your vessel surface, it will reduce the risk of CUI. And that's exactly what Pyrogel does because it's hydrophobic. It does not allow any water to penetrate into the insulation. But should water get underneath because of condensation or other reasons, there's an escape mechanism because it's breathable. And that's key. And that's what we'll focus on through the rest of the presentation, basically. If we look at two different surfaces here, one being a fibrous insulation like mineral wool, and this other being a Pyrogel base, the pink one here basically being the Pyrogel base insulation, you'll see what happens when a water event occurs. You have your cladding. I know everybody talks and doesn't tries to get people not to walk all over the cladding, but most sites I've been to, you'll see plenty of instances of the cladding being damaged. This causes a point where the water enters your system, and what you find is products like fibrous insulation will tend to absorb that water or moisture. Pyrogel will not absorb that moisture, but water and moisture could find its way between the joints or somewhere onto the pipe surface. And the key difference is that Pyrogel is breathable, so it allows that water to evaporate. It's 98% less water weight, less water uptake than the traditional mineral wool type of insulation. So when that system comes online, it's not spending all its energy evaporating that moisture from your pipe or vessel insulation. It's actually doing what it's supposed to be doing, which is giving you thermal performance and energy saving. So I'm going to talk to you about some of the testing that we've done in the industry. And the first testing I'm going to talk to you about is a testing that was done by Exxon. And this is a test where they were looking at really moisture uptake of the insulation. What they tested was two different types of insulation, one being Pyrogel against traditional mineral wool. They had these half pipes that you can see with the red sections insulated with different products, and they filled the half pipe with water for 3 days, left it dry for 4 days, and repeated this process for 80 days whilst heating the pipe to an 80-degree cycle as well. And what they found was that mineral wool never dried out. Even during that 4-day dry period, it never actually dried. And Pyrogel dried out within 3 hours or so. So straight after that 3-day water event, it was dry, which meant that it was not corroding your pipe. The energy was not being used. 1% of moisture in your insulation equates to 25% loss in thermal conductivity. So that energy now is not being used to dry out the insulation. It's being used to do what it's supposed to be doing, which is energy saving. This is another test, and this was done by Shell, and really they did something different. They were looking at corrosion rates. So you've got a pipe section here that was half painted with the coating and half unpainted. They heated the pipe to 80 degrees C, and they also poured saline water over the top. And they did this for also a 180-day exposure test, basically. And this is really to generate extreme corrosion. And what they found was the mineral wool, where it was coated, the corrosion rates were lower. So it was actually doing a job. It was actually, the coating was doing a role and stopping the corrosion rates. With cellular glass, the corrosion rates were much higher because obviously with cellular glass, the challenge is that although it won't let water in, any water that gets inside the system gets trapped underneath, and this causes severe form of corrosion, basically. And although the coating, again, once does a job, it's not doing enough to stop the corrosion rates. With Pyrogel, they found there was negligible amounts of corrosion, irrespective of the coating, basically. Now, what we're not saying here is that you don't need a coating, but what we're saying is having a good coating, having a high-performance insulation helps with the mitigation strategy against corrosion under insulation. The final test was a similar test that Equinor did, and I'm not going to go into too much detail here because I'm conscious of the time, but they did a similar test to Shell, and they got the same results, basically, as Shell did with Pyrogel, once again demonstrating low corrosion rates. If we look at where the corrosion rates are and where the risks are, basically where you've got mineral wools and so forth, the water uptake is higher, so the corrosion rate is higher. Where you've got the likes of cellular glass, the water uptake is very low because it's glass, but they're not vapor permeable, so corrosion rates are higher. And Aerogel really gives you both. It gives you low water uptake and also very good breathability, so the corrosion rates are much lower. Quickly going on to our case study, this was a case where we went to installed our products in 2008 in a site in Korea, and we revisited the site after 12 years. So what we found, and the case is case 2 and 6, case 1 and 8 that we're going to look at, where the temperature range is right in the CUI range. And we visited this after 12 years, where it was the same product that had been removed and reapplied several times during inspections. And you can see the temperature range there. It's 135 degrees, 20 millimeters of our product on there. The original design temperature was 31.2, and we measured 32 degrees and 33.8 with a probe and an FLIR. So it was performing as per the original design 12 years on. But I think the key thing also is that there was no corrosion there either. On both cases, they found no or very little evidence of corrosion after a 12-year period. I mean, this says 10, but this is an old slide, basically. So what we're saying, just to finish off, coatings and mechanical protection like cladding helps towards your effective CUI mitigation strategy. But what we're also saying, what's really important, as well as the mechanical protection and the cladding and so forth, is your insulation. And traditional insulation products are there, and people tend to use their coatings and mechanical protection to mitigate for the limitations of that insulation products, basically. We promote an effective CUI strategy, which says consider your insulation as part of that, mitigation strategy, which will give you that full protection. So it's a 3-stage process: your coatings, your insulation, and your cladding, basically. So I hope I haven't run over too much there, and I'm open for questions.
Well, as I said, Altaf, we'll do the questions later, and what I would say is please take the opportunity to put questions on the Q&A bit, and we can pick them up later, or you can go directly to Altaf. He'll be around, so you can go to Altaf, ask him any questions. Thank you very much indeed. We've had 4 very comprehensive presentations on 4 completely different aspects, but all extremely important to improving the lifetime of aging assets, and all very, very interesting, all very key issues, which I'm sure you're all dealing with. The next presentation will be at 11:30, and we'll be going into a different theme around TPM and lean, and then decommissioning. So more really good stuff coming up at 11:30. So take the opportunity to please go and talk to the exhibitors, talk to all the delegates, talk to the speakers who have already been. And I'll see you at 11:30. Thank you.
Thank you.